Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and back with a new tutorial. Presently we are studying marine auxiliary systems and deck machinery. Today we have 18th lecture and the topics are types of compressions, effect of clearance volume and multistaging on volumetric efficiency. In this tutorial, we will first learn about the basics of compressors. Then we will learn about the types of compression processes. Next, we will learn about the approach of polytropic compression to isothermal compression. Then we will learn about the advantages of multistage compression. Next, we will learn about the effect of clearance volume on air intake. Lastly, we will learn about the effect of multistaging on volumetric efficiency. Let's discuss these through the following slides. Function of air compressor. What is an air compressor? An air compressor is a mechanical device which increases the pressure of air by reducing its volume. The compressor is similar to a pump as both are used to increase the pressure of a fluid to transport it through a pipe. How is a compressor different from a pump? Main difference between pump and compressor is the change in volume of the fluid. Pumps are used to transport liquids which are relatively incompressible. On the other hand, an air compressor is able to reduce the volume of air as it is compressible and increases the density during the compression process. Which types of air compressors are used on ships? Air on ship is mostly compressed by reciprocating compressors. Although centrifugal compressor, screw compressor and lobe type compressors are used for specific applications. How is the supplied energy converted to the pressure? The energy supplied to the air compressor during the compression process is converted into heat as the volume of air is decreased. As the air gets heated, kinetic energy of molecule increases, which exert force on the cylinder wall, and this force is reflected as increase in pressure. The heat generated during the compression process has to be constantly removed for proper functioning of air compressor. Depending on the requirement, compression of air may take place in several stages. Air is cooled between each stage and subsequently after the compression too. Types of compression processes. The sketch shows three types of compression processes and compares the work required during each process. In adiabatic or isentropic compression, the enthalpy remains same, which means that no heat is exchanged from the system and the heat of compression is also stored in it. Adiabatic process follows the law PV raised to power gamma is constant, where gamma is the ratio of specific heat of gas at constant pressure to specific heat of gas at constant volume, whose value is 1.405 for air. The work of the adiabatic compression is given by the area of curve 0, 1, 2, 3, 1. In isothermal gas compression process, the temperature remains constant, which means that heat would have to be removed from the gas as it is supplied to gas during compression. This will require a slow moving piston and well cooled cylinder. Isothermal process follows the law PV is equal to constant. The work of isothermal compression is given by the area 0, 1 2, 3, 0. Actual or polytropic compression process lies between isothermal and adiabatic processes. It follows the law PV raised to power n is constant, where n has value of 1.3 for air. Work of polytropic compression is given by the area 0, 1 2, 3, 0. From this sketch, it is observed that isothermal compression requires the minimum work of all these compression processes, thus making it ideal compression process, although it may not be achievable. Approach to isothermal compression. This sketch shows the approach from polytropic compression to isothermal compression by having multistage compression. To achieve this, cylinder and cover of air compressor should be cooled to remove as much heat as possible, preferably by water. Air after each stage is also cooled, which helps to reduce the work of compression as shown in the sketch. When air is compressed isothermally in single stage, it follows the compression curve OBE, and the work done is represented by the area OBEFGHO. On the other hand, if air is compressed polytropically in single stage, it follows the compression curve OAD, and the work done is represented by the area OADFGHO. In order to approach the isothermal compression, air is compressed in the first stage along the polytropic compression curve OA, and its work is represented by the area OAGHO. Air is then cooled along the line AB, and the point B lies on the isothermal compression curve OBE. In the second stage, air is again compressed polytropically along the curve BC, and the work done is represented by the area B, C, F, G, B. We can observe that by compressing the air in two stages with intercooling helps us for saving in work given by the area A, B, C, D, A and an approach towards isothermal compression. Saving in work A, B, C, D, A is equal to work of the polytropic compression in one stage O, A, D, F, G, H, O minus work of compression in first stage O, A, G, H, O plus work of compression in second stage B, C, F, G, B. Thus we can say that it is better to compress air in two stages with intercooling instead of single stage, especially when high pressure is required. Advantages of multi-stage compression. Multi-stage compression offers several advantages. Some of the important ones are listed here. Saving in work done. Work done in compressing the air is reduced, which saves power consumption. Avoids several mechanical problems. Due to proper cooling, lot of mechanical problems such as thermal distortion of parts, overheating, etc. are avoided. Simplified cylinder lubrication. Due to low air temperature, less difficulties are experienced in lubrication of piston and cylinder. Reduced wall fouling. Low temperature of air reduces fouling and carbonization of lubricating oil and maintains valves in cleaner condition. Helps in reduction of moisture in delivered air. Helps in reducing the moisture of the delivered air, which is undesirable in compressed air systems as it causes corrosion. Increased volumetric efficiency. Multistaging is also helpful in increasing the volumetric efficiency of the compressor. Effect of clearance volume on air intake. This diagram describes the effect of clearance volume on intake of air during the compressor's suction stroke. Clearance is necessary to provide the expansion allowance for the piston due to the heat generated by the compression of air. Diagram 1, 2, 3, 4, 1 represents a theoretical compression cycle with no clearance volume. Thus, the volume swept by the piston and air intake is same, which is represented by V. Diagram 1, 2, 3, 4-1 represents an actual compression cycle in which clearance is C and the air intake is represented by V1, which is less than swept volume V. Diagram 1, 2, 3, 4 double dash 1 represents a compression cycle with increased clearance C plus X due to worn out bearing, and the air intake is further reduced to V2. It can thus be stated that for attaining best volumetric efficiency, minimum bumping clearance should be maintained. Effect of multistaging on volumetric efficiency. This diagram shows the change in volumetric efficiency by comparing the volumetric efficiencies of single and two-stage compressors working within same pressure limits. Volumetric efficiency of an air compressor is defined as the ratio of volume of air discharged as free air to the swept volume of low pressure piston. Free air delivery is the quantity of air at atmospheric pressure and temperature of 15 degree centigrade. Vc is the clearance volume formed by the gap between top of the piston and cylinder head. Clearance volume reduces the effective suction stroke of piston. Vs represented by process 50 is the sweat volume of pistons. V0 is the volume of cylinder equal to sum of swept volume of piston Vs plus clearance volume Vc. Vs0 represented by the process 5-0 is the effective suction volume for single stage compression. Theoretical suction volume of single stage compression represented by the process 50 gets reduced to the effective suction volume represented by 5-0 due to expansion of trapped air after the delivery of compressed air at point 3 along the curve 3, 4 dash, 5 double dash. Vs1 represented by the process 5-0 is the effective suction volume of first stage piston for the two-stage compression. Theoretical suction volume of first stage piston of two-stage compression represented by the process 50 gets reduced to the effective suction volume represented by 5-0 due to expansion of trapped air after the delivery of compressed air at point 4 along the curve 4, 5 dash. We can see that effective suction volume Vs1 of first stage piston for two-stage compression is larger than effective sweat or suction volume Vs0 of single stage piston. Thus the volumetric efficiency of a multi-stage compressor is higher than single stage compressor working within the same pressure limit. Actual compression or expansion curves. This diagram shows actual compression and expansion curves, and the effect of valve inertia can also be observed at the end of these curves. Theoretical compression is represented by the curve 1 2, whereas 2 2 dash is further compression to overcome the force of delivery wall spring, thus extending the compression curve to 1 2 dash. Theoretical delivery stroke is 2 3, whereas actual delivery stroke is shortened to 2 3. The pressure in the cylinder has to increase above the delivery pressure. Theoretical expansion stroke is represented by 3 4, but it is extended up to 4 dash to overcome the force of suction valve spring. Theoretical suction stroke is represented by the process 4-1, which is actually reduced to 4-1. Pressure in the cylinder has to drop below atmospheric to draw the air inside. This completes the study of the types of compressions, effect of clearance volume, and multistaging on volumetric efficiency. This book is written by me and covers all the topics as per the syllabus specified by Indian Maritime University. It clarifies the concepts with simple illustrations. The book also provides answers to all the questions which have appeared in the examination conducted by Indian Maritime University. The book can help the students in preparing for the exam and also to work on ship's auxiliary systems and deck machinery safely. Hope that you have liked the lecture. You can write your feedback in the comment box. If you have liked the tutorial, you may share it with your friends. You may subscribe to the channel for getting notification about the new tutorials. I will be back with a new lecture shortly. Thanks for watching till the end.